Hi friends, welcome to all. In this video we are going to see the packet tracer activity skills integration challenge. Here we can see our addressing table and we can see this addressing table is incomplete. We have to complete this addressing table. We will go through the background. This activity allows you to practice a variety of skills including configuring VLAN's PPP with a CHAP, static and default routing, then using IPv4 and IPv6. Due to the sheer number of graded elements, you can click check results and assessment items to see if you correctly entered a graded command. Use the Cisco and class password to access privileged exec modes of the CLI for routers and switches. Coming to the requirements, addressing. The addressing scheme uses the 192.168.1.0/24 address space. Additional address space is available between VLAN 15 and VLAN 1. VLAN 25 needs enough addresses for 50 hosts. Determine the subnet and complete the subnet table below. Here we can see that we have to complete this IPv4 subnet address for the VLAN 25. Here is the details. Complete the addressing table by assigning the following addresses to VLAN 25. For the router 2 R2 gigabit Ethernet 0/0.25 first IPv4 address. For the PC 25 second IPv4 address, L25 last IPv4 address. Configure IPv4 addressing on the necessary end devices. On R2 create and apply IPv4 and IPv6 addressing to the gigabit Ethernet 0/0.25 subinterface. First of all, we will complete this subnet table. Here is our subnet table in our spreadsheet. Coming to this, here we can see VLAN 15. Here we can see that which is having the maximum number of hosts. So here they started the first subnet 192.168.1.0 and here the maximum host should be 100. So the prefix here we can see it's /25. Here I added one more column for the range. Here we can see the subnet from the host portion 1 bit should be adapted. So here we can see that 255.255.255.128. So it support maximum 128 minus 2 hosts. That means 126. Here we can see that range from 192.168.1.0/25 till 192.168.1.127/25. Now we will see the next maximum host. Here we can see that it's 50. So we have to find the subnet for this VLAN 25. So we will use the next subnet here. Here we used 1.127. So here we can use 192.168.1.128. We need 50 hosts. That means 2 to the power of 6. Total we get 64. 64 minus 2 maximum we get 62 here. That means we have to get 2 bits from the host portion. We have to dept 2 bits from the host portion. So we get the subnet mask 255.255.255.192. So here we will give the range. It's 192.168.1.128/26 because we depted 2 bits till 192.168.1.191/25. Oh, it's 191/26. And in this addressing table, other VLAN's subnet address already filled. Now we will complete our addressing table. Here is our addressing table. Here we can see for the R2 gigabit Ethernet 0/0.25 we have to assign the first IPv4 address. Here we can see the device R2 and here is gigabit Ethernet 0/0.25. Here we are going to use the first address. Here we can see in our subnet table for the VLAN 25. Here we can see the subnet address. It's a 1.128. So here we are going to use the first usable IP address, that is 1.129. Here we are going to assign that. 192.168.1.129, and the subnet mask is 255.255.255.192. Next is PC25 second IPv4 address. We already used 1.129. Here we can see that. Now we will give for the PC25 the next address, that is 192.168.1.130. Then the subnet mask 255.255.255.192. Now we have to give the default gateway here. So the default gateway will be the IP address of this interface where this network is connected. That is this interface address. Here we can see it's 129. 192.168.1.129. Right. Next is a L25 last IPv4 address. Coming to our subnet table, here we can see here the broadcast address is 1.191. So the last usable IP address is 1.190. That we are going to assign for this device L25. 192.168.1.190. Subnet mask 255.255.255.192, and default gateway 192.168.1.129. Now our addressing table is completed. Now we will configure IPv4 addressing on the necessary end devices. Also on R2 create and apply IPv4 and IPv6 addressing 2 gigabit Ethernet 0/0.25 sub interface. Coming to our end device, first of all we will check on PC15 IP configuration. Here IP address is assigned. Now we will come to PC25 IP configuration. Here we will give the IP address 192.168.1.130. The subnet mask 192, default gateway 192.168.1.129. Now we will come to L25 config. Here we will give the IP address 192.168.1.190, and the subnet mask is 255.255.255.192. Also we will set the default gateway for this device L25. Here we can see gateway. Here we are going to give 192.168.1.129. Now we will come to R2 and we will create and apply IPv4 and IPv6 addressing for the interface gigabit Ethernet 0/0.25 interface. We will come to R2. Password is Cisco. Enable password is class. Here we will check show IP interface brief, and we can check the IP address details. Here we can see they set only for the interface serial 0/0/0. So we have to set for the interface gigabit Ethernet 0/0 sub interfaces. Right. First of all, we will come to configure terminal. We have to go to the interface gigabit Ethernet 0/0. We will go to the sub interface .1. Here we will give encapsulation .1q. That VLAN ID, here it's 1. Now we will set the IP address 192.168.1.193, and now we will give the subnet mask 255.255.255.224. Right. Now we will go to the next sub interface. Interface gigabit Ethernet 0/0.15. Here we will give encapsulation .1q VLAN ID 15, and we will set the IP address 192.168.1.1 and the subnet mask 255.255.255.128. Coming to the next subinterface, interface gigabit Ethernet 0/0.25 encapsulation.1q25 and IP address 192.168.1.129 as per our addressing table. Subnet mask 255.255.255.192. Coming to the next subinterface, interface gigabit Ethernet 0/0.99 as native. Here we have to give a encapsulation.1q99 native, and we will set the IP address 192.168.1.225. Subnet mask is 255.255.255.224. Now we have to give a no shutdown command for this interface gigabit Ethernet 0/0. Coming to the interface gigabit Ethernet 0/0 no shutdown, so that all the sub interface changed state to up. So here we can verify that. Show IP interface brief, and here we can see the details of our sub interfaces. Now we will check IPv6 address details in this router R2. Show IPv6 interface brief, and here we can see the details. Subinterface 0.1, 0.15. For 0.25, here we can see this IPv6 address not set, so we have to set for this subinterface. Then for 0.99, okay, and for the serial interface, so we have to set only for the subinterface gigabit Ethernet 0/0.25. Coming to our addressing table, here we can see IPv6 address for the interface gigabit Ethernet 0/0.25 for the subinterface exactly. So we will come to R2 and we will configure this IPv6 here. Configure terminal, we have to go to that subinterface gigabit Ethernet 0/0.25. Here we are going to set the IPv6 address. Here is that address. I copied it. No, it's not copied. I will copy from here. Right. Remove this address. Well, also we will set a link local address IPv6 address FE80:2 as a link local. In this router R2 we are using IPv6 address, so we must enable unicast routing for IPv6 routing. Well, for that we have to come to configure terminal, and to here we have to give the command IPv6 unicast routing. Coming to the next configuration, here we can see VLANs. On S1 create VLAN 86 and name it black hole. Configure S1 ports in a static mode with the following requirements. Here we can see that fast Ethernet 0/1 is the native trunk for VLAN 99. Then fast Ethernet 0/7 till F0/18 as access ports in VLAN 15. Then F0/19 till F0/24 as access ports in VLAN 25. Then gigabit Ethernet 0/1 and 2. Also from fast Ethernet 0/2 till 0/6 are unused. They should be properly secured and assigned to the black hole VLAN. Then on R2 configure inter-VLAN routing. VLAN 99 is the native VLAN. We will do these configurations on our switch S1 CLI. Password is Cisco. Enable password is class. configure terminal. We will create the VLAN 86 and we will name it as black hole. Now we will go to the interface, fast Ethernet 0/1, switch port trunk native VLAN 99, switch port mode as a trunk. Now we will go to the unused ports. We will exit and here we will give an interface as a range. We have gigabit Ethernet 0/1 till 2. Also we have a fast Ethernet 0/2 till 6. Right. So here we are going to add all these ports to VLAN 86. Switch port access VLAN 86. Well, switch port mode as access, and we are going to secure this by shutting down, because these ports we are not going to use. We will come to the next configuration. We will go to the interface, range of interfaces, fast Ethernet 0/7 till 18. Switch port access VLAN we have 15. Switch port mode as access. Now we will go to the range of interfaces, fast Ethernet 0/19 till 24. Your switch port access VLAN 25. Switch port mode as access. Now we will copy from running config to startup config. Next, here we can see PPP. Configure R1 and R2 to use a PPP with a CHAP for the shared link. The password for a CHAP is a Cisco. First of all, we will do it on R1. CLI. Password is Cisco. Enable. Password is class. Configure terminal. Username R2. Password as Cisco. Specifies an unencrypted password will follow, right? Cisco. Then now we have to go to the interface, a serial 0/0/0, which is connecting to R2. Here we will give encapsulation as PPP. Now we will go to PPP authentication as specified as CHAP. Now we will do it on R2. Cisco enable, password is class. Configure terminal. Here we will set the username R1. Password as Cisco. Now we will go to the interface serial 0/0/0, which is connecting to R1. Encapsulation as a PPP. Then PPP authentication as specified CHAP. Next is routing. On R1, configure IPv4 and IPv6 default routes using the appropriate exit interface. Coming to topology, here we can see the router R1 and here we can see the exit interface serial 0/0/1, which is going to this ISP. Right, coming to R1 CLI, here we will configure this default route, both IPv4 and IPv6. So we will exit from here. Here we are going to give IP route 0.0.0.0 space 0.0.0.0 space exit interface, as we have seen that 0.0/0/1. Now we will set for IPv6 route :/0 and the exit interface serial 0/0/1. Next is on R2, configure an IPv6 default route using the appropriate exit interface. So here we can see the router R2, and here is exit interface serial 0/0/0. Coming to S2, configure terminal. Here we will give IPv6 route :/0 default route, and the exit interface serial 0/0/0. Next is configure IPv4 Ospf using the following requirements. Use process ID 1. Routers R1 and R2 are in area 0. R1 uses router ID 1.1.1.1. R2 uses router ID 2.2.2.2. Then advertise specific subnets. Then on R1 propagate the IPv4 default route created. First of all, we will do it on R1. Right here we will give a router Ospf process ID 1. We will give the network 10.1.1.0 and the wildcard bit 0.0.0.3 and area 0. Now we have to give a default information originate. Also we have to set router ID 1.1.1.1. Now we will do it on R2. Router Ospf process ID 1, router ID 2.2.2.2. Now we will give the network. We have 192.168.1.0 and the wildcard bits 0.0.0.127, area 0. Also we have other networks 192.168.1.128 and the wildcard bit 0.0.0.63, area 0. Next network 192.168.1.192 and the wildcard bits 0.0.0.31, area 0. And we have one more, that is 1.224 and the wildcard with the same, area also 0. Also we have one more network, that is for the serial 10.1.1.0, wildcard bits 0.0.0.3, area 0. Next is configure IPv6 Ospf using the following requirements. Use process ID 1. Routers R1 and R2 are in area 0. Configure Ospf on appropriate interfaces on R1 and R2. Then R1 uses router ID 1.1.1.1. R2 uses router ID 2.2.2.2. First of all, we will do it on R1. We have to go to the interface serial 0/0/0, which is connecting to R2. Here we are going to give IPv6 Ospf process ID 1, area 0. IPv6 routing not enabled, right? That we can do. So IPv6 unicast routing, right? Now we will enable IPv6 router Ospf 1 and we will set the router ID as 1.1.1.1. Now we will do it on R2 CLI configure terminal. So we have to go to each sub interfaces. Interface gigabit Ethernet 0/0.1. Here we have to give IPv6 Ospf 1, area 0. Now we'll go to the next interface 0/0.15. Here also we have to give IPv6 Ospf 1, area 0. Now we will go to the next subinterface 0.25, IPv6 Ospf 1 area 0. Now we will go to subinterface 0.99, IPv6 Ospf 1 area 0. Now we will go to the interface serial 0/0/0, and here we will give IPv6 Ospf 1 area 0. Now we will exit and we will enable IPv6 Ospf. It's not Ospf, we have to go to IPv6 for enabling router. Yes, IPv6 router Ospf, then process ID 1. Then we have to give the router ID 2.2.2.2. Yes, almost we done the configuration, but here we can see the completion status is 96 out of 100. Anyway, we will go through the check results, something we missed out. First of all, on R1 Ospf router ID not set, right? That we will verify that. Coming to R1, here we are going to give the show command, show IP protocols, and here we can see Ospf 1 router ID. Oh, it took the highest IP address, so we have to set a specified 1.1.1.1, right? So we will configure that. Coming to the configuration, configure terminal. We have to go to router Ospf 1, and here we are going to set the router ID 1.1.1.1. But here we can see reload or use clear IP Ospf process command for this to take effect, right? So we will do that. Clear IP Ospf process. Reset all Ospf processes. Right. Now we will check the router ID, show IP protocols. Yes, now we can see it's router ID 1.1.1.1. Here we can see we have some more problem. Completion is 97 out of 100. We will go to check results, assessment items. So here we can see for the serial 0/0/0 area and process ID, right? We will do that. Coming to the router R1, configure terminal, we will go to the interface serial 0/0/0. Here we will give IPv6 Ospf, then the process ID 1, area 0, right? Yes, now we can see our completion status 100 out of 100. Well, so that's all in this packet tracer activity skills integration challenge. If you face any completion problem, you can go to this check results and we can verify where it's pending and we can complete that. So friends, if you have any doubt in this packet tracer activity, please comment below. Also, if you like my video, give a thumb and don't forget to subscribe the channel for future videos. Bye bye.